Hello, this is Dr. Mears. Today we are going to be learning about writing an equation given slope m and a point x, y. And this is going to be of a linear equation. This is the application. So we're going to read this real world scenario, and it kind of makes me itchy because it's about mosquitoes. Um, and then we're going to go through and do fill out the questions that it's asking you, just so that it could be used as a guide. I know you have a big project and the project doesn't guide you through, so you may use this as a guide to help you with your project. So let's get going. Reading the problem, the population of mosquitoes in a swamp grows at a constant rate. Every week the population grows by 200 mosquitoes. During week 15 there are 3,100 mosquitoes. Let X represent the number of weeks and Y represent the total population of mosquitoes. I'm actually going to do a read, reread, and annotate on this. So I just read it once. Now I'm going to reread it and annotate. So the population of mosquitoes in a swamp grows at a constant rate. So I know that I'm going to have some type of slope here. Every week, so that's one per week, the population grows by 200. So every week, so the week increases by 1, my population of mosquito increases by 200. This sounds like my constant rate of change. During week 15, there are 3,100 mosquitoes. This is going to be an X value, and this is going to be a Y value. And I'm going to tell you why. It's because X represents the number of weeks. So since X represents the number of weeks, they gave us a number of weeks, which is X. Since Y represents the total population of mosquitoes, they gave you a total population. So this is Y. So they give you an X, and they give you a Y, and they give you a constant rate of change. Let's see what they're going to want us to answer. Okay. For part A, what does the X variable represent? Well, the problem was really nice here because it actually told us that X represents the number of weeks, so I filled that in for you. And then B, Y variable represents the total population. Now be careful because some problems won't tell you blatantly like this what X and Y represent, so you're going to have to look for it. And when you do look for it, you have to look. It says every week, so we know as time goes on. And so that's going to be our number of weeks. And there's a total population here, or a total number that they give you, and total numbers are going to be represented using the Y variable. So you input a number of weeks, and you get an output of a total population. So number of weeks is our input, and the total population of it is our output. And remember, input represents the X, and output represents the Y. So just be mindful of how to pull out the definition of the variables. Okay, let's see what part C says. Part C says, as the population of mosquitoes increases by 200, this is your change in Y, so this is your change in Y. The weeks increase by 1, this is your change in X, change in X. So change in Y over change of X represents the slope, M. So this sentence represents the slope, M. So M equals, well, let's see what our ratio is. So change in Y increases by 200, so that's positive 200, divided by our change in X. Our change in X is an increase of 1, so over 1. So 200 over 1. You may reduce that to 200, which will be nice because we are going to be using that for our slope when we find our equation coming up. Okay, next part, let's pull out the point they gave us. During week 15, which is your X value, there are 3,100 mosquitoes, which is our Y value. So this sentence represents the point XY. So this is going to be your X, this is going to be your Y, because it is represented in a point. So where you see the X, you're going to put the 15, because that is our X value. And where you see the Y, we're going to get 3,100, because that is our Y value. So we're actually looking for that input of 15 and our output of 3,100. So we now have our slope, M, and a point, X, Y. Let's see what else they're going to want us to construct here. So part C. Now you need to substitute the slope and the point into y equals mx plus b to find the y-intercept. So if you went through and you did the skill portion of the video, the other video with us, you have practiced this skill. So this should be second nature to you. So what we're going to do in order to create an equation, we need to find this b because we do not have b. We have m, we have a point. We don't have our y-intercept. So let's substitute in the y value, which is 3,100. Let's substitute in our m, which is 200. And notice I'm putting the 200 in. We don't need to put this fractional value in because it is over 1, so it can reduce to 200. That makes doing the math a little easier. Our x value is 15, so this is going to be times 15. Remember, this is multiplication. And then plus b because we don't know. So we're going to take out our calculator. We're going to multiply 200 times 15, and we're going to get 3,000. So 3,100 equals 3,000 plus b. We want to bring the 3,000 over to the other side of the equation, so we're going to subtract it because that's the inverse operation of plus. We are going to get b equaling 100, which equals b. So on this line down here, I'm going to put 100. If you missed any of that, please pause, write it down, review the video, and relearn it again. If you're having trouble with this skill, you may need to ask me for more practice. Okay, let's go on. Part F. Now that you have slope, m, and y-intercept, b, please write an equation in slope-intercept form. So because we have y equals mx plus b, we're going to substitute the m and the b in so that we can get an equation. Y equals, our m was 200, times the x variable plus 100. So this is our equation to find, if we know the number of weeks, to find the total number of population of mosquitoes. Pretty neat. Okay, we're going to be using this. So if you flip your paper over, you're going to see that there's going to be a graph. And what I'm going to do is I am going to actually write down my equation up here. Y equals 200x plus 100. Because we're going to be using that equation to graph it. Please graph your equation below. I have set up the number of weeks. I counted by ones for my scale. I set up the total population. I counted by 100ths for my scale. I also have a title, swamp, and bugs. Can you please pause the video and fill out your graph? Okay, welcome back. Here we go. So we need to graph this equation. The first thing that we need to do is we need to get our start point. This is our start point. Our start point is our B. So we're starting at, we're starting at 100. This is the y-intercept at 100. So what we're going to do is we're going to go to our graph, to our y-axis, that's this right here. On this axis, we're going to find 100. 100 on this axis falls right here. I am going to make a point on this axis. This is my start point. This is the point I use to leap to go to any other point on my graph. So this is kind of like, I call it home base. So this is where we start and we'll go on from there. Well, from our start point, we need directions to how to get to another point on our graph. And the directions are going to be given by our slope, our m, which is why it's called a rate of change, because it's how the graph changes. It's the rate at which the graph changes. So let's check out the rate. We have 200 over 1. Please notice I did change it back into the fraction because this number in the numerator tells us how many we go either up or down. If it's positive, we go up. If it's negative, we go down. The number in the denominator here tells us either to go left or right. If it's positive, we go right. If it's negative, we go left. Okay, so the number at top, 200, it is positive. So we are going to go up 200. The number denominator is positive, so we're going to go right 1. Please, pretty please, do the up and down first. So let's do that. Then we're going to do the right or left. So first we're going to go up 200. But where do we start? We start from our start point, which is our home base. So from here, let's follow the set of directions that our constant rate of change tells us to do. So we're going to go up 200. So let's count. Here's 100, here's 200. Then from there, we're going to go right 1, right 1. Here's my next point. You have to do both of these before you write your little point, before you write this little dot here. Okay, so let's do it again. So from this point, let's again go up 200, right 1. Up 200, right 1. Up 200, right 1. Up 200, right 1. Now I ran out of graph. You could extend the graph. A lot of people are like, we could extend it. Yes, you can extend the graph. But this actually gives me 1, 2, 3, 4, 5, 6 points. So I'm just going to take out my trusty old ruler. And I'm going to connect the points with a nice line. I'm going to throw arrows to show that this line does continue. Sorry, just messed that paper up. Okay. So here is our line. It is increasing. It started at 100 because that was our start point. It increased, which means we went up 200, and then it increased right, or actually, yeah, ran right, right 1, up 200, right 1, up 200, right 1. So we used our start point, which is our initial value, as a home base, and then we did these directions. That's what our slope told us. So this is the line. Okay, let's see what we have to do next. After 20 weeks, what is the population of mosquitoes? Now you could do this one of two ways. First is using the graph. When we use the graph, what we have to do is they give us the X. Remember, the X is the number of weeks. So they say, okay, X is 20. So we're going to go over to, I can't go to 20 because this next one would be 15. We ran out of graph. So on that last application problem that I gave you the last video, we were able to use the graph. So we can't use the graph method here. So we're going to have to use our second method. Our second method is using our equation. Y equals 200x plus 100. So if you ran out of graph and you can't really extend it, I have no room to extend it. I could get a piece of graph paper and redo it. But if you run out of graph and you can't use it, we got to use the equation method. So knowing that my x is 20, we are going to use substitution. So where my x is, remember this is multiplication, 20 times x, I'm going to input 20. I'm going to rewrite 200 times 20 because that was the number of weeks plus 100. So remember, I'm inputting 20 and I want to see what my output or my total population is. This is going to give you 4,000. Do not forget you need to add that 100. So y equals 4,100. So my total population is going to be 4,100 mosquitoes. And I'm actually going to write that in a nice complete sentence, is 4,100 mosquitoes in week after, let's put after 20 weeks because that's what the question asked us. After 20 weeks. So I used my equation. I substituted in my x value. I evaluated it. I found that it came out to be 4,100. So my total population is 4,100 mosquitoes after 20 weeks. I wanted to use my graph, but I don't see that where the 20 weeks is located here, so that method couldn't be done. So I used my equation method instead, and that's what that was. Okay, last question. Is it reasonable to find the X-intercept? Why or why not? Now, let's just go back. The Y-intercept is where it crosses the Y-axis, where this line crosses this line, the Y-axis. So if we were looking for the X-intercept is where the line crosses the X-axis. Let's write that down here. X-intercept is where the line crosses the X-axis. So what we're looking for is we're looking for this line to cross this axis right here. And so if you look, I can extend it. So this line needs to cross this axis right here. But if I extend it, where does this line cross? It crosses over here on the other side of 0. And if it crosses on the other side of 0, we're talking about negative numbers. And negative numbers, when we talk about a population of mosquitoes, or negative numbers when we're talking about a number of weeks, do we have a negative number of weeks? So I don't believe it's going to be really reasonable because we don't have negative time. So this line would cross the x-axis at a negative number, and we don't have negative time. So let's write that down. So let's say, no, it is not reasonable because the line would cross the x-axis at a negative number, and we do not have a negative time, which in this case is number of weeks. So it is not reasonable because it would cross at a negative number on the x-axis, and we don't have negative time, or we don't have a negative number of weeks. So this has been the x-axis introduction. This has also been graphing using an equation. We also made an equation using slope and a point. As I said before, this is a good guide because you have a final summative project that you already have in your hands, and you do not have really steps to go by, so these are some steps that you may use. Hopefully it helped. Thank you very much, and I'll see you in class.